Before we get started, just a reminder that you can find all of my available rental properties on my website at marcguzman.com. If you own investment property, click on the Owner Services section to see our complete list of services. Thank you to our sponsor for today's episode, East Brother Beer. Located on Canal Boulevard in Point Richmond, East Brother Beer mixes classic brewing styles with precision and modern sensibility to create the perfect Bay Area craft beer. From landing on Mars to exploring the outer reaches of our solar system, last year saw all sorts of new discoveries in space science. 2019 is set to bring us even more breakthroughs in terms of what we know about the universe around us. Today, we welcome back on the podcast Ben Burress, one of the many staff astronomers at Chabot Space and Science Center in Oakland, to discuss with us some of the great discoveries made in 2018 and what is making astronomers excited for 2019. Ben, thanks for coming back onto the podcast.
Thanks for having me. It's good to be back.
So we've got a lot to cover, and for a lot of the people tuning in and listening to this podcast, if you haven't already done so, go back and listen to the first time we had Ben on the show. And Sam, if you can find what episode that number, it's already up there, episode 35.
Oh.
So episode 35, wow. Really, episode 35?
That a year ago, yeah.
A year ago, actually, we had him on January 11th was when we posted that episode.
Wow, we've done so many podcasts since then. I mean, this is going to be episode. Let's see, do you have it on my show notes already?
This is I want to say 194.
Woo!
Yeah.
Okay.
Wow. So we're rocking and rolling here.
Nice.
So thank you for coming back onto the podcast. We didn't even get through half of what we wanted to talk about last time. And I have a feeling today is going to be the exact same thing.
Yeah. I mean, talking about this kind of stuff, how can you get through even a fraction of it, really? What
Yeah.
you want to talk about, right?
Yeah.
There's a lot of things being talked about.
So let's recap 2018. What have been some of the big discoveries since the last time we had you on the show?
Big discoveries. Well, there's a lot of them, really. In terms of space exploration, things that we've accomplished, I'll kind of leave the big discoveries thing on the back burner for a second, but some new achievements and things that could potentially give us some new big discoveries. They're in the works right now, so we're still collecting data. So we've had at least a couple of asteroids being visited right now by a couple of different probes. The NASA OSIRIS-REx mission is orbiting an asteroid right now, asteroid Bennu. And one of the first things it detected there was hydrated minerals in its soils, meaning there's water there. It's a small asteroid, not very big at all, but and too small ever to have had water. But that may suggest that it broke off from a larger object in the past that maybe was big enough to have water. So the minerals were in contact with water at some time in the past. So in the hunt for water out in space, which is kind of parallel to the hunt for organic materials and, life, places for life, that is another big clue or piece of evidence, part of the puzzle of our solar system, where there could be life, where there may have been conditions in the past. So there's a chunk of it right now that we're going to get a sample from. OSIRIS-REx is actually going to touch down. I think it's been doing some practice maneuvers, but it's going to take a sample and bring it back to Earth. So we'll be able to see the sample in our labs. The Japanese Hayabusa 2 also is visiting another similar asteroid, and it's actually planning to touch down in a number of places and bring samples back to Earth.
When are these probes supposed to get back?
Oh, boy, the dates. I think OSIRIS-REx is going to be back in a couple years. Take some time to come back, of course. I don't have those dates written down, but in the next couple of years, 2-3 years, they should come back because they're still there at their asteroids at the moment.
Yeah, it's amazing to wrap your mind around how vast space really is. And then,
what did Douglas Adams say? Right now?
What's that?
What did Douglas Adams say? Space is so hugely big you could not possibly imagine. He goes off in this whole paragraph about how impossibly big it is, and you could never comprehend it. Yeah. Sorry to interrupt.
And yeah, it's just mind-boggling, like how big it is and how long it takes for probes to get places, get back. I mean, even Mars. I mean, It's 6 months to get to Mars from the closest point,
mm-hmm.
which is every 2 years?
Every 2 years it comes, closest to Earth. So that's when they tend to launch missions. That's the launch window. And you're talking about the solar system, tiny, tiny piece of all of space. The place we can actually send things to right now. We've sent robots beyond the farthest planets. And speaking of discoveries, or at least major events, that was one that happened just at the new year. If you remember NASA's New Horizons probe that passed by Pluto in 2015, just passed by the most distant object we've ever visited. It's a Kuiper Belt object, a cold, icy, rocky chunk floating out there way beyond Pluto, like 1 billion miles farther. I got some good close-up pictures. Found out it looked like a little snowman. It was actually 2 pieces stuck together, 2 kind of blobs of material. But that is the first time we've been up close to a standard conventional Kuiper Belt object, and there are probably millions of them out there.
That's amazing. I mean, we have no idea, like, everything really out there. I mean, as much as we've been sending probes out and how much our technology's advanced to understand what's out there.
Mm-hmm.
I mean, what would you estimate? We know 1 or 2% of what's out there, or?
Well, in terms of an inventory of what's out there, we have a small sampling of what we've been able to see through telescopes and visit with robots. And you can extrapolate that out to characterize what maybe the whole galaxy is composed of. So by sampling our neighborhood, how many stars or exoplanets or interstellar asteroids swinging through our solar system, we can sort of estimate what the galaxy is probably composed of. But no, we don't know. We don't have that inventory because that's a big, big chunk of space to get information on, especially when you're talking about, an object that may be a few miles across, like a comet or an asteroid or something.
Yeah. So what were some other discoveries or accomplishments for 18?
Well, another landing on Mars, the InSight lander. And it almost seems routine now, us landing on Mars. Oh, another robot on Mars. It happens every few years. It's not that frequent. But this one's different, actually, because of what it's going to do on Mars. InSight is designed to give us a peek inside Mars. So it's going not with, it has cameras taking pictures of the landscape and all that, but its main scientific instruments are a seismograph or a seismometer to listen to Mars quakes, and a Doppler experiment to make measurements of Mars's rotation, and a thermal probe that's going to bore down underground. And all of these sources of data are designed to give us an idea of what the internal structure of Mars is like. How big is its core? How hot is it still in there? How much has it cooled down in the time since it formed? And the idea being, if we can learn what is inside Mars now, how it's really structured, by extension, we can understand more about all of the terrestrial planets. So Mercury, Earth, Venus, Mars, because they formed under similar conditions. So it's not only a glimpse inside Mars, but it's almost like archaeological evidence to understand what was going on very early in the formation of our solar system, how the planets formed in the first place. We still don't know how a planet is put together.
Really?
Is it put together by, 100-mile chunk-sized objects that come in and smash together? Or does it come out of, dust? Is the dust just forming and forms a planet? We don't know the size of the objects that come together to build a planet when they do. We're learning more, not only from these archaeological, like air quotes, missions that look into the evidence of the past of our solar system, but we can also study other star systems and see, young star systems that may have a ring of dust around them, and we can get information about, what that dust ring is like. What are the chunks doing? Are they coming together into planets? So all of that is just designed to give us a better idea of where our solar system came from and how planets like the Earth came into being.
Now, what about megastructures and radio bursts?
Okay.
I feel like that's been popping up quite a bit in the news lately.
Yeah, they have. I mean, there have been some observations. Let's start with the radio bursts, the fast radio bursts. This has actually been a puzzle for years. They've been detecting these quick little blips of radio energy that typically when they would detect them, they'd detect one blip and it would never recur. And, they've been puzzling about, okay, what's making these blips? And so they've done a lot of study looking for the sources of where these radio pulses may be coming from. Naturally, somebody said, well, if it's a technological civilization, maybe it's a signal from there. Why not look into that possibility? If there's technological civilizations out there, I think there probably are. A radio blast could come from them. But, I think they're looking at natural sources for these things. They sort of located the source of where these things are coming from. They seem to be coming from other galaxies. And in fact, recently they've detected 2, maybe 3 repeating fast radio bursts. So a source that pulses multiple times or on a regular basis. These, by the nature of the radio waves that we detect, they seem to be coming from a place that has very powerful magnetism going on. So there's another clue. So these sources of these radio bursts, so whatever's actually causing the powerful burst of radio signal, seems to be coming from a place where there's strong magnetism. So that could be a neutron star. So we know about pulsars, which are neutron stars, the collapsed cores of very massive stars that are very, very tiny but very compact. And they spin very fast. I mean, multiple times a second or more. And if they have active radio sources on their surfaces or being generated by their magnetic fields, they're kind of like lighthouses. They spin around and they send out these beams of radio waves, and we hear a pulse. But pulsars are usually like very regular ticking of a clock because they are just spinning and lighthousing at us at high speed. These fast radio bursts, a lot of them are just like that one and done. We heard it, didn't hear another one again until more recently in the last couple of years, these repeating ones. So maybe there's a different source for the repeating ones versus the one-offs, or maybe the one-offs could prove to be repeating ones if we listen long enough. We know so little about where these are coming from, only really speculation right now. Could be a couple of neutron stars that are colliding, creating.
How far away is the source?
Well, I think one of the repeating ones was located about 1.6 billion light years away. So outside of our local group of galaxies, but from another galaxy. So black holes, whether regular black holes or those central massive black holes that they've been finding in the cores of galaxies, are potential environments where something powerful could happen to produce a radio burst. So like when a star is swallowed up by a black hole, when the black hole eats, there can be a powerful outburst of energy. So they're looking at things like this. And I think one person said there may be as many speculations about where these are coming from as there have been detections. And they found over 60.
Over 60.
They've detected over 60 of the single non-repeating ones, and then 2 or maybe 3 repeating ones at this point.
Wow.
So,
wow.
But what they are, they're still working on it. I think those ideas are good, the neutron stars, because you're looking for a very powerful event, and the magnetic field, powerful magnetic field being present is a very powerful clue too. So where do you look for powerful magnetic fields? Well, neutron stars is a really good candidate. So
Yeah.
So they're kind of zeroing in on it. It's a matter of these things come once, a lot of them, and then don't repeat. How do you study that? A lot of science is done by making repeated observations of the same thing. But if you only have one data point, one quick blip, maybe the character of that radio blip. A lot of these, last for microseconds. They're very, very quick, and then they're gone, and you're left with a big puzzle to figure out with that one little data point.
So how are we detecting those here on Earth?
Radio telescopes. So there's a number of radio observatories. I think the one that detected either the first or maybe the second of the repeating FRBs, fast radio bursts, is in British Columbia. It is called CHIME, I don't remember what the acronym stands for, but it's a radio antenna or an array of radio antennas. So set up mainly to do radio astronomy. So they're studying sources of radio waves out in the cosmos. But I guess from when they started this up, not too long ago, it's a new observatory for one thing. Within the first, I want to say, month, they detected 13 of the non-repeating FRBs and the repeating one they found. So it seemed to be happening a lot.
Is it happening more, or it's just?
I don't think there's any evidence of that. It's just we're getting more radio telescopes online and looking for these things.
And so now we're discovering more because of that.
Because we're listening for them, right?
Okay.
I don't think that the rate is increasing. If it is like neutron star activity or black holes eating up stars, there's nothing to suggest that this would be changing its rate. Yeah, this is something that would be kind of a background, static, pretty stable.
Now, what about the megastructure? Because that's what we talked about last time on the show.
Right.
Is they had just announced this big giant megastructure. There were a few people that were claiming, oh, this has to be alien. It has to be a different planet.
Right.
Something artificial. And then some people were saying, well, no, there's some scientific backing to show that. Well, I'll let you explain.
Yeah, I think it goes back to an observation that was made of a star that wasn't as bright as it should be for the kind of star it is. And I believe there were even like some fluctuations in the brightness that couldn't be explained. It's been a while since I read that one. But so the idea was, well, if this is one of those megastructures, and I think the classic example of one of these megastructures is the Dyson sphere. So the physicist Freeman Dyson proposed the idea of building a sphere around a star in order to, well, for one, capture all of its energy and make that energy useful to a civilization. So it would be this giant solar collector. It's basically collecting all of the star's light. Then I don't know if Dyson suggested this or if science fiction writers took it and ran with it. Imagining a civilization living on the inside of this sphere, on the surface of the sphere, with unlimited power and huge amount of surface area to live on. But then there have been other science fiction writers really ran with this idea, like Larry Niven's Ringworld. I was just talking about where it's not a whole sphere going around this star, but it's a ring, like a ribbon built around the star, and the living surface and the ecology is all on the inner surface of that ring, that ribbon. And in that case, we stumbled upon this artifact in our future. This is a science fiction story, and found the civilization had collapsed. So there was nothing there but tribes of devolved descendants going around. Really great story. I love it. But that kind of an idea, building something to live on, getting off your planet, your natural home, and having your civilization, or part of it at least, living on an artificial structure that is self-maintaining, using sunlight and a closed ecology, whatever.
Do you think eventually our race, the human race, will one day end up building something artificial?
Well, the really big blown megastructures, that would be a huge technical undertaking to build something that big, right? I mean, that's just
So no building a Death Star in the near future.
well, Death Star is tiny compared to these megastructures we're talking about. But even a Death Star would be a challenge, right? But I mean, there's other examples, both in speculative technology and science fiction, that are more believable instances of these artificial arcs. So if you saw the movie Interstellar, at the end of the movie, when they solved gravity and could get huge structures off the Earth, they had built these big cylinders that people were living in. So they were artificial structures. You can imagine maybe someday being able to build something of that size. I mean, here on Earth, we build buildings and giant ships of similar size, maybe. So it's something that technically we could do, and it would become an artificial environment out in space that people could live on, if you had a managed ecology on the inside and such. So whatever the size, the idea of building an artificial arc or world or mini planet or whatever has been around for a long time.
Probably a mini moon.
Mini moon, right? But yeah, as far as the star that was observed that people suggested, well, maybe that's a megastructure that's blocking the light. They also did measurements of the infrared, how that, if it's a structure, then the captured solar radiation has to turn into heat somewhere, and you might be able to detect that. But I think later on there were further observations or further analysis that they said this is probably a disk of dust and rock orbiting this young star that's getting in the way, basically blocking the light at times or dimming the light.
So no alien spaceship.
Well, we don't know. We don't know. I mean,
Yeah,
that's the thing, right?
I feel like every time there's some kind of radio burst that's caught, or some change in light that it's not so easy to explain, everyone just rushes, oh, it's got to be an alien. I feel like our society at this point is just waiting for the one day where we just discover that there's intelligent life.
Wouldn't that be a day? Well, see, it's a double-edged sword, because on the one hand, you make a detection like this, fast radio burst, or this star that's not as bright as it should be. And, well, what do you say if you just, taking the science aside for a minute, just talk about what's most likely? What's the simplest explanation for what we're seeing? I think by and large, especially in the scientific community, I think the simplest explanation moves toward the natural explanations. But the double-edged sword part of it is, the existence of other technological civilizations is a real possibility. So if they are really there, then why couldn't they be the source of some of this intrigue that we're seeing up in the sky? So I guess sometimes it comes down to what you believe is the likelihood of there being a technological civilization. I think from what I've seen, life exists should be able to exist pretty broadly out there. We've found a lot of exoplanets that have conditions that may be very similar to the Earth. And if we know that on Earth, life appeared very early, as soon as the conditions became right, life just kind of sprang out. So if it's really an easy thing for life to appear when you get the right mixture of chemicals and water and energy, then you should expect there's a lot of life out there. Now, how many intelligent or technological civilizations may be out there? That's part of that whole Drake equation, where they try to use math to figure out the likelihood of being able to contact or hear an extraterrestrial civilization based on...
I think the problem with that math, though, they determined that our entire galaxy would be populated.
Well, it depends on what numbers you put into the equation, right?
Okay.
And that's the thing. It wasn't really... I think a lot of people didn't think of it as a real scientific equation. It is, but more than that, I think it's the human race trying to grapple the possibility of what's around us in the galaxy by putting math in there, and putting in real data when we know it. How many planets do we know or extrapolate are out there? How many of those may be Earth-like? Along those lines. And we're getting more and more data to put into that equation. So it is a scientific equation, just that most of the variables we really don't have any scientific data to support. So some of the variables are just whatever number you want to put in there until we know more, right?
So we also had Curiosity that found organic material on the Martian soil.
Mm-hmm.
So what are we doing with that information, and what really is this organic material?
Right, yeah. So the first thing, people hear organic material and they think life right away. It doesn't necessarily mean life. It's material that they found in the rock samples they were taking with Curiosity that are organic materials, are hydrocarbons, basically. So organic for life on Earth means molecules of hydrogen and oxygen, or sorry, carbon and hydrogen. Got that. Water is hydrogen and oxygen. But so these are like hydrocarbon compounds. So on Earth, it's like methane, ethane, octane, all the way up, all the anes. And but on Earth, for life, those are the building blocks of life on Earth. So, life structures on Earth are based on these hydrocarbons. So, and there's different compounds, combinations of these hydrocarbons with other minerals and whatnot. And that's some of the stuff they found on Mars. And what they're doing with it, well, this is all part of the more broad, search for life. Because that's the next mission that's going to Mars. It's specifically going to look for signs of life. That's the Mars 2020 rover. So in about 2 years, 2020. So Curiosity wasn't designed to look for signs of life or analyze for signs of life. It has the equipment to be able to say, hey, there's organic material in the soil here. But it was mainly sent to assess the environment on Mars, in particular the past environment. So it was looking at the rocks and the minerals and the strata or the geography of the area and the geology to see what was happening in the past. At what point did Mars become a cold desert, and what was it like in its youth? We now understand it to have been a very wet planet, or much wetter than it is now, with surface water and maybe water cycles and all the ingredients for life. Whether or not life did arise in Mars's early seas, we don't know yet, but that's what we're looking for.
Yeah, I've heard a few people say it was very similar to what Earth is today.
In some ways, yes. I mean, I don't know if we know much about the atmospheric composition. So on Earth, of course, we have a lot of oxygen in our atmosphere and mostly nitrogen. The oxygen comes from photosynthesis. So living organisms on Earth are creating the oxygen. Mars's atmosphere now is very thin, and it's mostly carbon dioxide. So we do know that in the past there was liquid water. So there's evidence of rivers and lakes and shallow seas, at least, which would mean a thicker atmosphere. Also means it was a lot warmer. It'd have to be warm enough for liquid water to exist and not freeze, right? So it looks like a very, at least in terms of the water and the temperature, favorable conditions for some form of life. Other things you're going to be looking for and have been looking for are, well, what was the chemical composition? How acidic or not acidic might those seas have been? Were the waters of that world conducive to life or not? Were they poisonous to life?
So we have Curiosity.
Mm-hmm.
We have, is it Insight? That's the one there now?
Yeah, Insight just landed.
Okay.
Mm-hmm.
And then what's the one for 2020?
Mars 2020 rover. Physically, it'll look a lot like the Mars Curiosity rover. It's built after the same blueprints, I think, but it will have different instruments.
So what instruments are they going to use to try to find life on Mars?
In the case of Mars 2020, mainly what it's going to be looking for is like chemical or mineral evidence of past life on Mars. So, it's not going up there with like, if you're going on a safari to look for life present there today, whether those are microbes or anything else, you might have a certain set of instruments geared to looking for that. I think they're really very interested in what life may have existed in the past, mainly because the conditions in the past were so conducive. So if there was ever life on Mars, it would be in the past. There may be life on Mars today, we don't know. And they're certainly looking for signs of that as well, like methane plumes coming from under the soil. And gosh, if they take a microscopic picture of a rock and it shows a fossil, cool, that'd be great. Or even a living creature crawling along. But yeah, this mission will mainly be looking for signs in the past. So fossils, I guess you could say, but the mineral version of fossils. So the residues left behind by whatever may have been living there in those seas or even on the land potentially.
Yeah, it's amazing what you can do with science and just tracing that back and just realizing, oh, this belonged to something that lived here.
Right. Well, any mission that's gone with a camera or a microscope or a drill, if there were fossils in those rocks, there was the chance to see them. We haven't seen that. The two Opportunity and Spirit rovers had rock drills and microscopes where they could look up close into the rocks. They weren't looking for fossils. I keep saying fossils because I love fossils, and I think that would be a very clear sign that there was life on Mars at one time, right? But yeah, they're taking a much more laboratory, mineral, chemical approach to seeing what was there. Because, frankly, if there was life on Mars in the past, it may have only been single-celled organisms, for instance, and that would have been probably billions of years ago. What's going to be left, even in the form of fossils? Fossils tend to change over time, and you might only be left with, well, for instance, petroleum on Earth is the leftover plant life. It doesn't look like a plant fossil now, but it is a residue. It's an organic residue. But otherwise, it's just a pool of black liquid, right?
Mm-hmm.
So they're looking for the substances that may have been left behind.
Okay.
Yeah.
That makes sense.
Mm-hmm.
Yeah, I feel like in the coming years, and correct me if I'm wrong, but I feel like there's going to be a big boom in a lot of space exploration. I mean, you have other countries like even China that are now jumping back in and sending probes. They just landed on the backside of the moon.
Right, which is a first ever accomplishment. Landing on the far side of the moon.
I thought we did that
Not on the
before.
far side, no. That's the first time that anyone's put something down on the far side.
They've taken pictures, though, right?
From orbit, yes.
Okay, so
yeah, they've
that's
flown
where I'm
around the
confused.
back.
Yeah.
Exactly.
Okay, but it was the first time that they actually landed there.
Right.
Okay, I saw one of the photos on Twitter. It was pretty amazing. Yeah.
Well, the challenge of landing on the far side of the moon, of course, is you don't have a direct line of sight with Earth. So you can't communicate with Earth directly from your landing site. So there has to be a relay, relay the information, relay station. So
Like a satellite?
a satellite, yeah. Mm-hmm.
Yeah. What do they expect to find on the backside? I mean, what's that probe there to do? Other than to
I'm
be
not
an
clear
expensive
specifically.
camera.
I mean, it was, I feel it was one of those kind of, let's do this because it hasn't been done. As far as the scientific value, there is a difference between the near side of the moon and the far side of the moon that's been seen from orbit. So the moon is tidally locked with the Earth. That is, it's been going around the Earth a long time, and over
But it doesn't
time,
rotate.
It does rotate.
Oh, it does.
But at exactly the same rate that it goes around the Earth. So it's always presenting the same face to us. If you imagine...
That's what I mean, yeah.
Exactly.
Yeah.
It's like a tether ball. This is my analogy. If you're swinging or you hit a tether ball and it's going around the pole, the rope tugs on the ball and keeps the same face facing the pole all the time. So the moon does that. There's a physical difference between the near side and the far side. The thickness of the crust is different because of the tidal forces with the Earth over time, especially back when the moon was, getting tidally locked with the Earth. That pull of the Earth's gravity and the tidal forces deformed the moon a little bit, changed its internal structure. So the crusts, I think the crust on the far side is actually thicker. There's a lot more big lava plains on the near side from lava that bled out from impacts and formed these lava plains. So in many ways, especially up close, the far side of the moon is unexplored territory. I mean, yeah, we have pictures from orbit and probably a lot of data too, because there's been a lot of satellites recently that have been doing like gravity measurements and all sorts of high resolution images. So we've seen it from orbit pretty well. But actually going down there, it's unexplored on the ground. So, and it's a great headline too.
Yeah.
First ever, right?
Yeah. So yeah, I mean, I feel China's doing this. NASA's trying to send more probes up into space for a wide range of purposes.
Right.
We have Elon Musk with SpaceX. I believe China also announced it. And now I believe NASA wants to kind of do it. I don't know if they have plans, but basically together send people to Mars.
To Mars, yes. Or the moon. I've heard of talk about the moon too, but I think there's been a lot more. Elon Musk wants to send people to Mars.
Yeah, and now that you say the moon, I think that sending people to Mars has sparked a conversation to, well, why don't we go back to the moon?
Right.
And I think there's even some concept drawings of what a lunar station would look
Mhm.
like.
Oh, there've been a number of those over the years, and more recently, they have refined that. But the talk about the moon, Mars, and beyond, that was I think a campaign slogan from a presidential campaign years ago. Was that Clinton or Obama? I'm not sure. Sorry, or maybe that was George W. Bush. But the idea was to get to Mars and potentially beyond with people by using the moon first. So using the moon as a stepping stone, a resource, because there are materials on Mars. We now know there's water on Mars, frozen water in some craters. The components of rocket fuel. So the idea is if you had a base on Mars, you could set up a manufacturing facility to build rockets, generate fuel, and launch from the moon. I meant the moon. Launch from the moon, which has much less gravity than the Earth, so it doesn't take as much to get off the surface.
Oh, less fuel then.
Right, less fuel, smaller rockets, and then launch to Mars from there. I think the talk more recently has been, well, why not just fly straight to Mars? And I think they're still looking at the moon and its resources as a potential base for that.
Because you would
kind
still
of
have to
thing.
launch from the Earth to the moon anyway.
Right. But the idea is if you could build the infrastructure on the moon to have a perpetual base, at least, that could, like I say, make rocket fuel from the water on Mars. Also, human supplies like water. You don't want to send water with your humans to Mars. They need to drink it, and oxygen. So there's a lot of material on the moon that can be used for a mission to Mars.
Yeah, the level of planning is just huge. I mean,
Well, it is a big undertaking.
yeah. So speaking of the moon, we have a super blood wolf moon coming up,
Ah, yes.
January 21st. It's in. Well, actually, when's this episode going to air? It's going to air after, right?
Yes.
Yeah, because
Yeah, it's
January 21st. Is
January
just around the
21st,
corner.
Greenwich Mean Time. Be careful. It's actually the evening of Sunday, which is the 20th.
Okay.
So from our time zone and our local time, it'll be on the 20th. So yeah, the announcements for the 21st were it's Greenwich Mean Time because it'll actually be past midnight in Greenwich.
Yeah, and they're like
England.
8 hours ahead of us.
Right.
So.
Okay.
Yeah, so it'll be Sunday evening. We'll actually have an event at Chabot, weather permitting. The forecast called for showers during the day on Sunday, but it looked like it was potentially going to be partly cloudy in the evening. So we're still crossing our fingers on that. But we'll be open from 6 to 11:30 p.m. on Sunday.
So, I think for most people, we've heard of a supermoon. Most recently, we've been hearing more and more about the blood moons.
Yeah.
Just because they look like they're bleeding red. But now this is the first time I've actually heard one with an animal name in it.
Oh, the wolf moon.
The wolf moon. So how did it get the wolf moon name?
Well, different full moons of the year and in different cultures have been given names. Now, you've heard of harvest moon, perhaps. So the full moon around harvest time, toward the end of summer, beginning of... There's actually the full moon that takes place at this time of year will be called the harvest moon. And it seems every month, every lunar month, every full moon, or a full moon that falls within a month or at a given time has a name like that. I don't actually know the origins of wolf moon. Blood moon is I think something that's been more popular than historical. I don't know how long people have been calling it blood moon, but
Just because of the bright red.
yeah, the red color kind of I guess we could do a little research and find out maybe it's been called that for a long time. But yeah, the supermoon part is also not a scientific term. It's actually it's a lunar perigee full moon or a lunar syzygy moon. It's a little less roll off the tongue than supermoon. But basically, it's a full moon that takes place when the moon is closest to the Earth in its orbit. So at perigee, which is the closest point it comes, it orbits the Earth, as opposed to apogee, when it is farthest from the Earth. The moon's orbit is an ellipse. The Earth is a little off-center in that ellipse. So there's one point every month that the moon swings by its closest point, and one point every month its farthest point. And when full moon coincides with one of those, in this case, the lunar perigee full moon, it's called a supermoon. because it's a little bigger. It appears a little bigger and significantly brighter because it's closer. I did
Doesn't
the
that
math.
have like extra effects on our tides?
A little bit.
A little bit?
It is a little closer, so the gravity is a little bit. I don't know what that measurement is right now.
You know what? Maybe it's a wolf moon because people turn into werewolves, right?
Well, that can happen anytime, right? Yeah, every full moon is a wolf moon, right? But
So Chabot has a event on Sunday then.
yeah. Sunday evening we'll open up at 6. Our observatory deck, weather permitting, we'll be open weather permitting. If it's raining, we can't see the moon, so there won't be an event. But we're hoping it'll at least become partly cloudy, because that actually could make a really beautiful experience. If you got this blood red, lunar eclipse happening with beautiful clouds drifting by, as long as the cloud's clear enough for us to see the moon, it should be really spectacular. So we're looking forward to that. But yeah, this eclipse coincides with the supermoon, so the eclipse itself will appear a little bit bigger than average.
What time would be the time to start looking up at the sky to see it?
If you want to catch it at its best, that is during totality. That's when the moon is completely engulfed in Earth's dark shadow, the umbra. It starts at 8:41 p.m., and it lasts for about an hour. But in the hour or more before that and after that, it'll be partly in Earth's shadow. So you'll see, part of the full moon blocked off. It'll look dark. It won't look red yet. But once it gets into totality and the bright full moon part kind of goes away, then those red tones will come out and you'll see that. The red color, by the way, is really interesting. It comes from Earth's atmosphere. It's the same source of a red or orange sunset or a sunrise that you might see. So the Earth's atmosphere filters out the blue light and lets the red light pass through more. And so that which passes by just grazes the Earth and goes through the atmosphere. The atmosphere acts like a piece of red glass. So the light that goes on is more reddened. It also bends the light into the shadow of the Earth. So that shadow is not completely dark. There's actually this red light. If you were on the moon during the eclipse looking back at the Earth, you'd see this ring of red, which is all the sunsets and sunrises around the Earth at that time in a ring.
Now, how does the atmosphere filter out that red, or filter out the light to where it appears red? Is that because it travels a longer distance through the atmosphere?
No, the bluer tones of light is shorter wavelength. It is affected more strongly by particles in the atmosphere, including air molecules. It's called Rayleigh scattering. So blue light at shorter wavelengths is more strongly affected when it passes through an atmosphere or a field of particles. It gets scattered in all directions. That's why the sky is blue during the day. You're seeing the light from the sun that was the bluer tones being scattered in all directions, including at your eye. But removing that bluer light from sunlight leaves what's left more red. So the red tones pass through almost unaffected or less affected. So it really is like a piece of red glass. If you hold it up to a white light, you'll only see the red light, because that's what's reaching your eye. The bluer tones are being blocked.
Wow.
Yeah. Think about that when you're watching the lunar eclipse.
Yeah. So what are other celestial events for 2019 coming up that people should be aware about and check out?
Well, there's every year, of course, we have our meteor showers. There's a handful of good meteor showers to catch. I don't know if you want me to list them out here. In the spring, we have the Lyrid meteor shower in April 22nd. The Aquarids on May 6th. And further out, there are other ones. There's the Perseids. Everyone knows the Perseids, right? So in August, around August 12th, it's one of the most reliable meteor showers of the year.
Now, what causes these meteor showers to happen every year as regularly as they do?
When Earth passes through a stream of dust left behind, usually by a comet. So as a comet goes around the sun, particularly when it gets close to the sun, it starts to outgas. Its ices are vaporized and turned into a gas, and that blows off the comet, carrying dust with it that's embedded in the comet. So it's leaving this dust trail behind it as it orbits the Earth. So it's kind of like if you remember the Peanuts comics, the character Pigpen.
Yeah.
He'd walk around with this cloud of dust pouring off of him. It's kind of like what a comet does in a way. So there's this trail of dust left behind in the comet's orbit. when Earth passes through that trail, basically we run into those particles and they burn up in our atmosphere. So you see a meteor when one of those little particles, and these are like the sizes of sand grains.
Wow.
They're really small. So, some might be your fingernail size. A typical meteor is very small, though. But it hits the atmosphere with such speed that it is intensely heated up. The glow you're seeing is mostly from the atmosphere that is heated up by the passage.
So it's not
of
even the
thing.
particle itself.
A little bit of it is, but there's not a lot of material in a grand sand grain, right?
Yeah.
It's the heat of that impact and this particle that whips through the atmosphere, heating up the actual atmosphere. It's a combination. I mean, there is some material left behind that's glowing for a bit.
Wow.
But my analogy is, and you have to be in the early morning hours to see a meteor shower, because that's the side of the Earth leading into the dust cloud as you go. My analogy.
I never actually thought about it that way. That actually makes sense, though.
Well, it's like when you're driving along on the freeway in your car and you hit a cloud of bugs. They hit your windshield and leave streaks on your windshield.
Yeah, and the back of your car is fine.
Yeah, exactly.
That
so it's
makes
those
total
morning
sense,
hours that
actually.
are the windshield. But yeah, the Perseids are pretty reliable, sometimes called the Old Faithful of meteor showers, because they pretty reliably put out 50 or 60 meteors per hour under good dark conditions.
So hypothetically, could there ever be a day where like there's just like all the dust in that area just kind of runs out? I mean, there's only
potentially.
be so many particles, right?
Well, the dust lanes are periodically resupplied when the comet comes back.
Oh, okay.
Yeah, so Halley's Comet is the source of one meteor shower, and it comes back every 76 years. Basically, what it develops this sort of lane of dust that orbits the sun as well. It's kind of creating this donut-shaped stream of dust, and it would take a long time to deplete it.
So it's not just like sitting there; it's all part of its own thing.
Yeah, it's orbiting the sun as well, but it's kind of moving along like a train.
Okay.
And the Earth happens to just go through it every year.
Yeah. And, we go through a pretty small piece of it. It's wider than the Earth is. So when we come back, there's certainly more dust particles to hit and see more meteor showers. Some meteor showers, like actually one coming up is the Leonid shower. It's in November. Its comet comes by every 33 years. And about every 33 years, there's this chance for an exceptional meteor shower or meteor storm. When you can see many sometimes per minute. I remember my grandfather telling me he saw it in 1933 when it came by, just after the comet came by. And he said it just looked like meteors were radiating out of the sky. I mean, it was maybe hundreds or thousands per hour. And then 33 years later, it was 1966, I was 4 years old. It was back. We went out on our porch to watch the meteor storm, and it was overcast in Oakland. So whatever happened, I didn't get to see it. But they put on a pretty good show the last, 99. So 99, 2000. It was actually 2 years running where it put out quite a few meteors. This year, the typical one is about 15 per hour. So it's pretty sleepy at this time. But then on in December, there's the Geminids. And so as far as astronomical events, there's a really rare one coming up in November. It's still a ways out, but it's called the Transit of Mercury. So Mercury and Venus, being planets that orbit closer to the sun than the Earth, occasionally or periodically can be seen to cross the face of the sun. Most of the time not. Most of the time, because of the tilts of the orbits and the alignments and all that, they pass above or below the sun and will not do that. So a transit is a planet's version of an eclipse, sort of. So if you're looking at the sun during this event, you would see a little black dot move across the sun over, an hour or 2 or 3, or whatever it happens to be. Venus does it less frequently, every 120 years or so. There's a pair separated by a few years of events.
Will we be able to watch that?
Yes. Actually, I have the times here.
Now, is Chabot doing an event for all of these or for some of them?
Some of them. We usually do an event for the Perseid meteor shower and potentially like the Geminids in December. We very likely will be doing an event for the Mercury transit because that's a very rare and crowd-pleasing event. You can't really see it. Well, you can't see it directly with your eyes because it's the sun you have to look at, and that's blinding. We do provide filters for people to look through, so you can actually see this little dot. But also we train our telescopes on it, and we will show a magnified telescope view of the event as it's happening. Yeah, it doesn't happen. It's quite a few years. It won't happen again after this until 2039. So
2039.
Yeah, they're long time between transits just because of the geometry. This is a choice alignment of Mercury and Earth and the Sun. But it's really interesting. Actually, historically, it was a transit of Venus, back a few hundred years ago. Well, actually, the observations were done 100 and some years ago, but that allowed astronomers to triangulate the distance to Venus and the Sun based on all the geometry and by extension, know the scale of the solar system. So before that, we didn't really know how far away the Sun was or the planets, but by doing this trigonometry, this math on the geometry of the Venus transit, we were able to plug in the numbers, and suddenly the whole solar system came into scale, and we knew how far away the planets were. It's very cool.
Wow.
Yeah.
Now, let's talk about the mysterious object. How do you even pronounce this?
I pronounce it Omuamua.
Omuamua?
Oumuamua, yeah.
So where did it get its name, and why is this a big deal?
So where it got its name, that's easy. Oumuamua is a Hawaiian word. I think it means messenger or visitor, or both. Why it's a big deal is, even if you leave out the some speculation that it could be an alien spacecraft visiting our solar system, which would be amazing, right? If you just say, well, it was a natural object. This is the first time we've actually seen up close an object from outside of our solar system, so an extraterrestrial or interstellar traveler. Most of the comets, well, for all I know, all of the comets, I believe, that we have observed that come by the Earth or that we've seen are actually in orbit around our sun. This one, they tracked its orbit after detecting it and saw that it had a highly hyperbolic orbit, which meant it came from beyond our solar system. It was not bound, it does not orbit. So it came from somewhere else out in the galaxy.
And this is really the first time we've ever detected something like this?
At least up close. I mean, we have detected, dust and exoplanets around other stars with telescopes. So yeah, we have detected, at least indirectly, material objects out there. But as far as something that has come from interstellar space really close to us, I mean, it passed closer to the sun than the planet Mercury. It's about a quarter of the distance between the sun and the Earth. It passed by the sun. And unfortunately, we didn't detect it until after it had passed the sun. Actually, it was on its way out. So they didn't get as much observational data on it as they wanted. And it was too far away when they actually, had discovered it and could point a telescope at it and get pictures to get anything more than a dot of light. So we have no up-close pictures of Oumuamua to see what it looks like. But by measuring the change in brightness, they determined that it's rotating. So as it rotates, and it has maybe different brightness on different sides, like a lighthouse, the brightness would change. So by measuring the change in brightness, we can measure that it's rotating. But also by measuring the difference in brightness, we get some idea of its shape. So one of the shapes that came out of this is it's a very elongated object. So it could be long, and I think people have said cigar-shaped. Or, potentially could be pancake-shaped as well and give us the same or similar readings. So it's about a quarter of a mile long, maybe. They're not absolutely sure of the length because it's all based on the brightness as it rotates.
But they know it's an interstellar object.
Right,
And
that's
from a different
entirely
system.
because of its orbit. Yeah, they can measure, an orbit of something going around the sun will be an ellipse generally. Well, it will be an ellipse. Whether very elongated or nearly circular, it's an ellipse. And if you just kind of track for a while an object that's going around, you can extrapolate that shape of the orbit all the way out and see whether or not it's an ellipse or a nearly circular orbit, or if it's a hyperbola, which means it swings by the sun like a horseshoe, right? Horseshoe shaped, but its ends are way out in the galaxy. So it's not a closed loop. It came from way out there, and it's heading back there now. But yeah, it never got close enough for us to take pictures of. They were able to get some spectroscopic readings, and they got a color off of it. It's very kind of reddish. It has a reddish tone. Some speculation is it spent so much time in interstellar space that cosmic rays just over time, and this could be millions or billions of years that it's been flying around out there, have reddened some of the material on its surface. But it was very unusual, because it was the first time we'd seen something come through our solar system from outside. And they're looking for more now, of course.
Yeah, and going back to what we were just mentioning earlier, is that probably the more and more our technology advances, the more and more we're going to see a lot of these different objects.
Mm-hmm. That's already happening, yeah.
Yeah, and then we're going to, because this probably wasn't the first time something interstellar has ever come into our solar system.
Probably not. In fact, there's actually another object. I believe it's orbiting Jupiter. I'm not very clear on that fact, but it's in our solar system now, and it's bound in our solar system, I believe. But the peculiar orbit it has around, I think, Jupiter, sorry, I'm not researched on that one right now, makes them think it may have come from interstellar space and then been captured into an orbit and is now permanently in our solar system. But they're not sure. That's speculation as well. So, yeah, if it happened once and it's a naturally occurring object, then over millions or billions of years in the past, it's hard to imagine that it hasn't happened before.
Now, I saw something recently that I believe the rings of Saturn are starting to decline or come apart.
Or, dissipate, fall
yeah.
into Saturn.
What's causing that?
I think it's probably just a dissipation over time. The rings appeared, they believe, when a moon got too close to Saturn and was torn up by tidal forces. So it was ripped apart. And it may have been a very icy moon. Most of Saturn's moons are icy objects, so a lot of water ice in them, and dust. And so when it broke apart, it formed these rings. But rings in general are not stable structures. Eventually they will dissipate. The particles will deorbit, fall into Saturn, or be flung by a passing moon or something out into other parts of the planetary system.
So at some point, Saturn can lose its rings.
Yeah. Probably won't happen anytime soon. I think we're talking about hundreds of thousands or more years.
Billions of years.
Yeah, well, not billions, probably much quicker than that. But certainly, like I say, hundreds of thousands or millions, which is a short period of time in astronomical terms.
Oh, it is, yeah.
Yeah. All of the gas giant planets have rings, but Jupiter's and Uranus and Neptune, they're so thin, perhaps they've already dissipated to that point where they're almost gone. Or maybe they weren't very big to begin with. We don't know. We can't see that part of the past, right?
Yeah. So, Sam, do we want to do the little spin the wheel? So one thing we've been doing on this show is we spin the wheel, basically get a topic that comes up, and then it's a new little segment we're doing on each episode here.
See if we know anything about it, right?
Yeah. Yeah, the last one we did was kind of fun. It was, what was one thing that what was a lie that you believed as a kid?
Oh. Okay. I was immediately beginning, how am I going to answer that? That might not be the question I'm asked, right?
Well, the one thing that we discovered on the last show was that many of the lies came from our moms.
So is the moms.
It'll be okay. Well, I can think of one right off, but anyway. Oh, here we go. How much will I win?
Yeah, we should connect prizes to this wheel. Ignoring distance, what planet do you want to visit the most?
So other than Earth.
Other than Earth.
Okay. I'm an earthbound soul. I love the Earth. My grandfather used to ask me, you still want to go to the moon? And for a long time it was, yeah. And then eventually it was, no, I want to stay on Earth. I think, and are we talking about just in our solar system or, yeah, because our planets are the ones we know most about anyway. I would probably want to visit Mars. Mars sounds like a really cool place.
The next step.
Well, it's the next step, and it's potentially very Earth-like. And on the one hand, I'm like, well, maybe I should pick a planet that's so different from Earth that the experience would be very different. Why would I pick one that seems to be like Earth's deserts, right? Mostly because, well, Mars is big in our eyes because of all the exploration that's been done there, and we're getting to know it so well. I mean, I might change my answer and say Venus, because the surface of Venus is such a different environment than the Earth. That could be really compelling. It's just that, and we're also assuming that I'd be able to survive standing on this planet, right?
Yeah. Well, let's assume you had the equipment, the suit to survive.
I think I'd still pick Mars, just because right now it's one of the number one spots for looking at past life, at least, and maybe even present life. Now, there's some really interesting moons out there too, but that said planet. So yeah, okay, I'll stick to planets.
Yeah, I think for me, I'd be torn between Venus and Saturn. I'm torn between those two. Venus, just because just getting closer to the sun would be pretty amazing.
Well, and this environment could be really amazing.
Yeah,
just what it looks like down there.
Yeah, and Saturn, just because the photos are just beautiful.
Yeah,
the rings, the shape of it. And the thing that is amazing is the hexagon of Saturn.
The polar storm system.
Yeah, and I think and that's the North Pole, right?
Yeah, I think it's the North Pole.
And the South Pole is just a circle, but the North Pole is the hexagon. Right?
Yeah. I don't remember there being stories from people that must be created by an artificial civilization, right? I didn't hear that story come out, but every time something on Mars looks vaguely like a face, you hear people saying.
Remember, it's a portal.
It's a portal. That's it.
A portal to another galaxy, another dimension. It's the Twilight Zone.
Pluto would be interesting too, by the way, but of course it's a dwarf planet. And I remember from a very young age saying it would be really cool to go to Pluto just because it's so far away, maybe so different. But after New Horizons went by and showed us that Pluto is much more interesting than we even expected. I mean, it has potentially flowing glaciers of nitrogen and methane on its surface, and maybe ice volcanoes or water volcanoes. I mean, it sounds like a wonderland.
Yeah.
So I'd be torn, actually, between those two. But I'll still stick to Mars, okay? I'll stick with Mars.
Now, isn't there some discussion about bringing Pluto back into the planet status, or maybe there's like a subcategory of dwarf planets that they want to?
Well, it is. That's what it was classified as in
Dwarf
2006 planet. As a dwarf planet. And I tell people who are upset that Pluto's not a planet anymore, well, it is still a planet. It's a dwarf planet. Because, I mean, if you look at the rest of the solar system, the 4 planets closest to the sun, including Earth, are terrestrial planets. The big gas planets are gas giant planets. Now you have Pluto as a dwarf planet. So there's another classification that was already being done. Somebody made the argument that, well, Pluto went from being the tiniest, puniest planet to one of the kings of the dwarf planets. It's potentially the biggest. If Eris is not bigger than it, then it could be like the best of the biggest of the dwarf planets.
It's probably sparked the most conversation here on Earth.
Definitely.
Planets.
Oh, definitely. But and it is really interesting. So after the flyby in 2015, people were saying it's a world. Forget this planet stuff. It's a world. We go to Mars and we see Earth-like deserts and an atmosphere and clouds and stuff. That becomes a world to us. And now Pluto is so interesting, at least in my eyes, but I'm sure many others, that it is a little world. Pluto is a small world after all. Sorry. I've said that before. I didn't make that up right now. So. Yeah.
So January 21st is right around the corner. But then what's the next big event that's going to be held at Chabot?
At Chabot, I have a little list here. We have, that's not it. Probably at the bottom of my pile, yep. So we have an ongoing, every month we do a $5 First Friday. So Friday evening from 6 to 10, we have a themed event. It's a lot of fun. There's live music, there's bars we have set up around, and if the weather's good, you can still go look through the telescopes. but we have themes. I think the theme coming up for February 1st is the science of hip hop, the science and art of hip hop music. So there'll be a lot of chances to get in and make your own music with special people, artists and musicians.
Well, that's going to be a lot of fun.
Yeah. So every month we have a different theme, and that's ongoing every first Friday. We also started a new series called Lectures and Lasers. Where are they? Every month, I believe. Lectures and Lasers. There'll be a different lecturer. Not really sure where the lasers fall in, but I haven't been to one yet. We haven't done one yet. The first one is actually this Friday.
Are you going to have lasers there, though?
We have lasers. Actually, we have a music laser show projector system in the planetarium. So somehow I think that'll be part of it. Otherwise, why it would be called lasers. Valentine's Day. If you're looking for something to do with your partner, we have Valentine's Day love missions. So we have what's called a Challenger Learning Center. It's a spacecraft and mission control simulator. And usually we just have groups of people doing space missions. Couples who come to do this will do space missions. The mission is to Mars, but there'll be, champagne and wine and hors d'oeuvres and special emphasis on the holiday, the Valentine's Day holiday.
That's a great mission.
It's a lot of fun. Yeah. Yeah, people have a good time at that. Also, we have we've been doing this annually for many years now. The Bay Area International Children's Film Festival is on the weekend of February 15 and 16. So all weekend we have curated, mostly short films, children's films from all over the world. And it is a lot of fun. We have 2 theater venues, and they also run workshops, sometimes in animation, other arts around filmmaking. The topics aren't necessarily science or astronomy based. They range all over the place, but it's very entertaining, and kids enjoy it, families enjoy it, I enjoy it. I'm in the planetarium running the projections in there, so I have a good time. That is on Saturday and Sunday, February 16 and 17. That's right, 16, 17. Weekend, right? I said 15, 16 before. It's the whole weekend. Yeah. So it's the 16th and the 17th. Then Tinkerfest. We've done 1 or 2 Tinkerfests now. It's a big come and build things, take things apart, learn about technology, get your hands dirty. Last year we had people taking apart the engine of a car right out of the car in the parking lot. We had a jet engine they brought in for us to have people take tools to and take apart. So it's a lot of fun. It's a big technology. It's kind of a reverse maker fair.
Yeah.
Because you're taking things apart. You're putting some things together. That's Saturday, April 13th.
Awesome.
Yeah.
And now all these events are available on the website.
Yes.
Perfect.
They are there.
And what's the website?
www.chabotspace.org. So CHABOTSPACE.org.
Perfect. And we'll go ahead and link that up. Now, before we end, so this marks the 50th anniversary of the Neil Armstrong walking on the moon. So
yes.
Do you remember watching that?
Oh, I do.
How was that experience for you?
Well, my little anecdote is we were in our living room on our little black and white Zenith television, the kind that takes a minute to warm up, the old tube televisions. And it's after they've landed Apollo 11, and we're waiting, and we're waiting, and we're waiting, and the camera, nothing's happening, and you can hear some chatter between NASA and Apollo. And I turned around to my dad and I said, "What are they doing? Why are they taking so long?" And he said, "They're probably playing poker on there or something inside the lunar lander." But I remember that clearly. And finally, they came down the ladder and walked around, and that was really amazing. But I remember just absolutely falling in love with NASA, during that whole exercise. All of the Apollo missions were interesting. But I remember having lots of toys. I had the little G.I. Joe Mercury space capsule, an astronaut, suit. That was very cool. I've seen those in antique shops now.
Well, that was one of the main goals of NASA and the U.S. government back then with the space missions, is to make a point and to showcase, who America really was.
Yeah, it was the competition between us and the Soviet Union, right? Who was going to get to the moon first. And And there are those people out there who don't seem to believe we've gone to the moon, or some of them don't know. You get quite a range. Some people either don't believe or just don't know that we've been to the moon. Other people I talk to assume we've already been to Mars. So there's a level of public education we have to work on here. But
there's a fun conspiracy theory for you. We've already been
to Mars. And what we found there, no one wants to know, so we're keeping it quiet, right?
It's inside. It's underground, just like the moon.
That's right.
Everything's underground, the hollowness.
What do you tell people if they say, "Oh, we didn't land on the moon"? Like, how do you respond to that?
Well, lately I've been asking myself, what would I ask them? I would ask, why don't you believe we landed on the moon? I know that I've heard a lot of the arguments of conspiracy theorists about, pointing out things in pictures about, you can't see the stars in the sky. Why can't you see the stars? That must be evidence that it was faked. Or
the flag.
Why is the flag blowing in the wind and there's no atmosphere on the wind? There's simple explanations to all of these things. I personally have no reason to believe we didn't go. I think there's plenty of evidence. There's so many thousands of people involved in the mission itself. Could it have been faked at the last minute because they figured, it's not going to work? It could have been, but I don't believe it was.
Yeah.
Well, what are the explanations then?
Right.
Like, they say, there's no stars in the background. Like, what's the...
Well, that's just a camera contrast thing. When you have a bright foreground and a dim background, the contrast and the brightness have to be changed so that you're not blowing out the landscape, but that makes the stars goes away because they're so dim.
Yeah, it happens all the time. On my iPhone today.
You can demonstrate it on your iPhone.
Well, then how would you explain the flag then? Just for
foil. It was a foil flag.
I did not know that.
It was meant so that it looked like it was blowing. They'd planned for that.
I did not know it was a foil flag.
Otherwise, it would have just been hanging there, looking pretty uninteresting. But yeah, there's a metal foil in there. It was either foil or wire. I don't know which, but it was something to give it the rigidity and make it actually look like it's rippling. That was planned. They knew they were not going to have atmosphere and wind blowing the flag there. So,
yeah, that would have been a big surprise, right?
Yeah.
If they plan this big mission, go to a different to the moon,
right?
And they're like, "Oh, we brought the wrong flag."
Oops. Hey, who put the Soviet flag in here? Yeah. But yeah, so I would ask that: explain to me why you think we didn't go. There's a lot of people alive today who weren't born at the time, so this is something that happened, way in the past. It's like for us in World War II, that happened a couple decades before I was born. So it's another era. It's a whole thing. What you have is, people telling you. You have survivors from that era telling you their stories. And you have pictures, lots of pictures and video and movies.
But I feel like it happens with a lot of things where something happens, then generations later, they just hear stories about it. Mm-hmm. They're not quite sure if it really did happen because they didn't experience it.
Right.
Maybe the people that their parents or grandparents that did experience it, they may not be around. And then all of a sudden, these theories brew up. And it's not something that, it's not because if we were going to the moon every single year and landing, different story.
It'd be a different story, right?
Yeah.
Why didn't we go back? Right.
Exactly.
I guess in some cases it may be a matter of if you don't understand how it was done, you might not believe it's possible to be done. Therefore, naturally, you would think it didn't happen, right? So partly it's
and that's a whole nother education problem, right? The education gap, because you're talking about the brightest people putting this entire project together to literally send humans off our planet to a completely different environment that we're not meant to live on. And that's what the brightest people are doing. And so for the other 99.9% of the people that are just living life and doing everything here on Earth, we see that and it's like, okay, I don't understand half of what they're doing. So a certain percentage of those people are then going to come up with their own theories as to, that's impossible. It's got to be fake. And then you have the attention seekers that just make really good YouTube videos.
Right. Well, then you have maybe a cynic who, because, the whole space race and the landing on the moon was a big political struggle, may, just not trust what they hear right? I mean, this was not a scientific exploration. This was a political triumph or attempt at triumph, right? So somebody who's cynical just might not believe it because of the political part of the formula.
But if you have a big enough fan base, you can kind of use this as a free ticket to go visit NASA, like like Curry did.
Yeah, right? I didn't hear that he actually took Mohawk guy up on his offer.
So he
Bobek.
said, yeah, he came out later and he did say that it was a joke.
Yeah,
what I said.
heard that.
And he said he was going to take him up on the offer. I don't know if he really has.
I would.
Yeah, I would too.
Yeah, my wife and I visited JPL last October. It was a fun trip. We got a little inside tour from our friend, but especially for space geeks and science geeks like us, loved it. It's a lot to see there, but it's just such a fascinating place. So much comes out of it. I mean, there's other places, of course, that produce really wonderful space missions, but so much seems to come out of JPL that really grips my imagination. A lot of the Mars missions and others.
So we'll wrap up with this final question. What is your prediction of something new we could learn this year?
Well, I think based on missions that are going on right now that are in process. So we're in the process of gathering the data on a couple of asteroids. So Bennu and Ryugu 2, the Hayabusa target. And then InSight has just landed, and they're preparing to start a couple years of data collection to basically give Mars a sonogram to get a three-dimensional picture of the interior of Mars. That'll be eye-opening. We've never seen inside another planet before. We've done this a little bit on Earth, using earthquake vibrations and seismographs to get a picture of the core and the mantle and the densities down there.
And have we done this on the moon?
I have not done this on the moon. We've detected moonquakes, but I think it was mainly a detection of the fact that there was a tremor or a shock wave of a meteorite. That's something else that InSight could hear is, potentially a shock wave that came from a meteorite impact, which it's all good. If it's detecting sound waves coming from inside Mars, it can use those to help develop this picture. So the more shocks, the better, whether it's a Marsquake or magma shifting or a meteorite impact. All of those are sources of sound waves or seismic waves that will be the data that InSight picks up on, and scientists can put together into an interior map. We don't know what it looks like inside Mars, how big the core is. And there's a lot of guesses, a lot of educated guesses and models, but having more data on that, like I said, it will give us a lot of insight, just so to speak, to understand how Mars came together, how its process of formation, took place, and by extension, other planets like Earth.
I think it's funny that when you hear of Martians, you always think of little green aliens like the movie or
Right.
little gray aliens, but some kind of aliens. But it's going to be funny that really the first Martians are going to be just humans living there like in 50 years or something.
Unless there's microbes still living on Mars from the past.
True.
It's a possibility.
We'll find out in 2020, I guess.
Hopefully. I mean, that's a step in the right direction. I mean, it's a big planet, smaller than Earth, but it's a big planet, and we're of course just landing on these little spots. They try to select the landing sites to maximize what they're looking for. With InSight, it didn't matter where it landed because it's looking at the interior. It wasn't sent to look at this debris flow or this sedimentary mountain or whatever. It could have landed anywhere and done the same work. So they're choosing where to land the Mars 2020 rover to give it the best chance of finding those leftovers from life, or better, living things. I don't know.
Yeah.
I mean, life on Mars, if it ever existed or if it exists now, is probably, you would expect, microscopic, single-celled. Because even on Earth, life on Earth was microscopic, single-celled for most of the planet's history. It's only relatively recently that multicellular life forms came about. So,
Well, Ben, thanks for coming on to the podcast.
Thanks.
It's been a pleasure having you back on. And we'll link up the website for Chabot so people can go check out these events.
Great.
And we'll include the dates of all the events, too.
Okay.
Dates, yeah. Yeah, perfect. So, thank you.
All right. Thank you very much. Appreciate it.
Thank you so much for listening to the podcast. Thank you to our producer, Sam Lubman. Please subscribe, like, comment, and share the podcast. Remember, you can listen to the podcast on iTunes, Podbean, iHeartRadio, Google Play, SoundCloud, and anywhere else you listen to podcasts. For more information on my business as a property manager and real estate team, go visit my website at marcguzman.com. I really want to thank all of you for listening. It means the world to me, and I hope today's episode provides you value in your day-to-day life. I created this podcast to help showcase the many great people that live in this world and help share some knowledge that I've learned along the way in life. Again, thank you for listening. Check out our sponsors, and I'll catch you on the next episode.